Okay, let's see in this video. If an equation is non-exact, then how do I proceed? Can I make it exact using anything? Or how do I proceed? Just leave everything and walk off? Is it like that? Or can I make it exact? When will I say it is non-exact? When I have dou m by dou y not equal to dou n by dou x. See, if I have this, then I'll be calling it to be a non-exact differential equation. Then, if it's a non-exact differential equation, there are certain criteria which I can check. First criteria is the function homogeneous? See, actually, guys, what I was talking about in the definition of an exact differential equation is dy by dx is equal to f of x comma y kind, where dou f by dou x would be written if I differentiate f and if I can get it to be m, and then if I differentiate f with respect to y and can get n, then I will say the equation is exact dot dot and all the things. Okay. Now, when I have it to be a function, now I'll check whether this function is homogeneous. If it is homogeneous, then damn sure 1 by mx plus ny works as an integrating factor. What exactly is an integrating factor? When certain criteria are not satisfied, what I'll be doing is I'll be multiplying with a term and then make the criteria get satisfied. That's what is an integrating factor. Or in other words, suppose if I have something like 2 by 5, I'm not comfortable with it, then I'll go with writing it like this. Okay, it's one and the same, but then I'm doing a small manipulations for my convenience, like how you do things in your chain rule. Integrating factor is also similar kind, where you will bring it to a certain criteria of your choice by multiplying with the integrating factor. Now this function, if it is homogeneous, what is homogeneous is, suppose if I take tx comma ty in f, and if I get it to be t power n, means what? I can rewrite the function as it is by writing this t out and t power n. Okay, then I can say f is a homogeneous function. Homogeneous function of degree n. Okay. Okay. I'll tell you in a very shortest way what that is when will I say it's a homogeneous function? Is simple, guys. Every term has the same degree. Suppose if I have something like this. If I have something like this. One second. If I have something like this, and then if I have something like this. Okay. You can observe the degree of all these terms is 3 only. Yes or no? Yes. So when the degree of all the terms in a function is same, then I can say it is homogeneous. It's a basic way of defining, layman way of defining a homogeneous function. Okay. Now, of course, the definition goes like, if you are able to rewrite, take t out and rewrite the function back in the same format, then it would be called homogeneous. Now, if in the given problem, if I find that the given function is homogeneous, then I can proceed with this integrating factor, is what I am trying to convey here. Okay, let's see a problem and understand what exactly I'm trying to say. Okay, I'll consider a problem, whether it's homogeneous or not, let us see, and then proceed with the things. Okay, so I have something like solve x plus y into dx plus y minus x into dy is equal to 0. Clearly, you can observe every term power is only 1. So, it's a homogeneous function. So, first thing, let me check whether it is exact or not. Dou m by dou y is what? Dou m by dou y is 1. What's dou n by dou x? It is minus 1. What is m, by the way? It is x plus y. What is n? It is y minus x. Okay. Both are not equal. Hence, it is not exact. So, what do? I will go for making it exact using an integrating factor. Of course, Bernoulli's is also the same thing. Linear is also the same thing. Again, we can talk about all those, but as of now, it's non-exact, and I can clearly observe that the given function is homogeneous. I'll rewrite it like this. You will understand, guys. Dy by dx is equal to x plus y with a negative sign by y minus x. Of course, I can remove negative sign. by writing it as x minus y. Is that fine? Okay, now this is the function f of x comma y about which I was talking. It's homogeneous. Okay, so what do I do? 1 by mx plus ny would be my short integrating factor. What's an integrating factor? Multiplying the whole equation with this integrating factor, I can make this equation to be exact. That's the criteria. What's mx plus ny? M is what? X plus y. X squared plus xy is mx plus ny is what? Y squared minus xy is ny. Okay, xy and xy goes off. I'll be left with 1 by x squared plus y squared to be the integrating factor. What should I do with the integrating factor? Multiply the equation with the integrating factor. X plus x square plus y square dx plus y minus x by x square plus y square dy is equal to 0. You can check for, let this be m1, let this be n1. Check for exactness again for m1 and n1. Dou m1 by dou y. How do I do it? UV rule I have to be applying. Okay, UV rule I have to be applying. I'll just show you. What's UV rule? I'm sorry, U by V rule is what? U prime V or V U prime minus UV prime by V squared. Okay. U prime is what? With what I'm differentiating with respect to Y. This is my U. It is 1. Into V is what? X square plus Y square minus. U is what? X plus Y. Into V prime is what? V prime is the derivative of X square plus Y square, which would be what? With respect to Y now, so it would be 2y by x square plus y square whole square, right? Dou n1 by y, dou n1 by x would be what? Same thing, u by v rule. But here I am differentiating with respect to x. So I'll be having a minus 1 into x square plus y square minus x square plus y. I'm sorry, y minus x into y minus x into, with respect to x now, so I'll be getting 2x and then x square plus y square whole square. Just simplify it and see what happens. X square plus y square minus 2xy minus 2y square. Okay. So what I'll be getting, just see x square minus y square minus 2xy in the numerator. Denominator is same for both. Of course, x square plus y square, okay, minus 2xy minus 2xy plus 2x square. Okay, there's a minus sign for both of them, right? So plus 2x square minus x squared would give me x square, minus y square is there, minus 2xy is there. I can clearly see both are same. Of course, denominators are same for both, guys. On the numerators I was checking. I will just write here what that is. Dou m1 after multiplying with the integrating factor, dou n1 by dou x. Both are equal. Hence, this would be exact. Exact. So, how do I write the solution for it? Integral m1 dx plus integral n1 y. This is equal to m1 keeping y as constant. I'll be integrating here terms independent of x. Every time you should write this. Okay. So, what I have in the numerator, what I have is x plus y I have. Okay, I have to be integrating it with respect to c. I have x by x square plus y square plus y by x square plus y square dx. This is also dx. This can be written as f prime of x by f of x, guys. And then in this, there is no term independent of x. So 0 into dy, this is equal to constant. This carefully I will integrate. I can write this as f prime of x by f of x if I multiply and divide by 2. Okay, so it would be log x. And this would be just integration of 1 by x square plus y square because y is a constant. Okay. Integration of x square plus y square. X square, it would be nothing but a integration of 1 by x square plus y square would be log or tan inverse x square plus a square kind tan inverse. Okay. I'll just write, please see here. Y is as it is. I'll be having tan inverse x by a. In the place of a as a constant, y is there. Of course, I'll be differentiating this as well. Differentiating it and writing in the denominator. Okay. Yeah. So what I'll be getting here? X by a. In the place of a, I have y. So x by y, if I am differentiating, I'll be getting y here. Okay. So this is equal to C. Now this value is what? 1 by 2 log or ln whatever ln x square plus y square. This is y and y goes off plus tan inverse x by y. 1 by a into I'll have now 1 by a. A in the place of a, y I have. Okay. This is equal to C. This is how I will solve when the function is homogeneous. What is homogeneous? Very simple. Every term will have same degree. Like how every term here had only degree 1. Okay. I'll do one more problem in the next video.